just like in the side character guide, there's a corner that
What'd you use?
House of Usher.
That's good.
Albert got the blind man prompts and put it back in the
Are the papers from last class just at the bottom of the shelf?
What did he use?
I try to put them in the folders over there. But you need to know
The
binder
folders.
numbers.
Okay.
You see on the chair, one of the boxes says AP.
You
Yeah.
really didn't know anything about Greek mythology in class. What can I say?
That's actually I love to learn about violence. And the specific injury is easy, but like the other injury, the other violence is hard.
Which story did you use?
Well, for the violence one, you could use two because you're trying to like display two things.
yeah.
So I used that Jesse had in Horror on the Shade because it ended up killing her, and it was like very specific reason why the author did that. And then for the accident one, I did
Lincoln.
flat and dies and the leather and it like smells, and it's just to like last.
Okay, I need you guys. One of the things I asked you to do for homework was to turn in that book work, which was number 38 into Google Classroom. But if you forgot or your internet wasn't working or something like that, this will be your last chance to still get full credit on it. So if that fits your scenario, make sure your name's on it and come turn it in before we get going here. But most of what we're going to look at today is practicing more of the related rate stuff that we did last class. But before I ask you to continue on that number 41 worksheet, I want to talk a little bit about some of the geometry formulas you need to know. And give you some tips for knowing the volume of some 3D shapes so that there's less for you to memorize. And then I've got a quick card sorting activity that is on related rates, trying to pair up a scenario to a geometry formula to its derivative. And then once we're done with that, you'll have the rest of the class period to work on that number 41 that we started on last class. So, okay, last call. Any other number 38s? Okay. All right, so this number 42, there's not too much here, and honestly, I might have to ask you to add something to it later. There are a few things that there are a few formulas they do not expect you to know for our AP exam, and we are very consistent with this on our test. The ones they expect you to know are the ones we will expect you to know. One of those is the volume of a sphere. They always provide the volume of a sphere formula. But some of them that they don't is if you have a right triangle using Pythagorean theorem. And as I mentioned last class, this is the most common type of related rate, starting off with a squared plus b squared equals c squared. They also will expect you to know the area and circumference of a circle. So if you don't remember those, you need to rememorize them. Square, you need to know the area and perimeter. I feel like perimeter goes without saying because you just add up all the side lengths, but. And then on a couple of these, I left them blank because I want to give you kind of a tip that will help you with three-dimensional shapes. I probably should put cylinder here too. Volume of a cylinder, I think they do need you to know that one. Alright, now surface area of a cube. Again, this one's just like adding the area of all the sides. So a cube has 6 sides. Side times side is how you'd find the area of one square, and a cube has 6 squares. So that's why that's the one that it is. I hope that you don't feel like you need to memorize that. But when it comes to three-dimensional shapes, there's really two main types of three-dimensional shapes. Prisms are the things that have two bases, and pyramids, which has one base. Regardless of what type of prism it is or what type of pyramid it is, the volume of both of these is capital B times H, but the pyramid one is always times a third, where capital B is the area of a base. So if it has two bases, a prism, bases are the sides parallel to each other, the volume will be the area of one of the bases times the height. And if it's a pyramid and it only has one base, it will also be the area of the base times the height, but times a third. That's the only difference. So with that in mind, let's look at these over here. A cube is a three-dimensional shape. This has two bases. You could think of this side and this side as bases, so that makes it a prism. So his volume is going to be the area of the base times the height. And since this is a square, if we call this S, what's the area of the base? Okay, side squared. And times the height. The height is also S in length. So side cubed. The area of the base, which was side squared, times the height, which is side, gives you the volume of a cube. Okay, whereas a cone, cone only has one base, so his volume will also be area of the base times the height, but since it's a pyramid, one base, it will be times a third. And what is the area of his base? So that's how you can know the volume of a cone without really memorizing another formula. And then a cylinder, how many bases does a cylinder have? How many bases does a cylinder have? Two. Okay. So that means his volume is capital B times H, where capital B is the area of the base, so pi r squared. So that helps you with basically all three-dimensional shapes with volumes. If it's got two bases, it's the area of the base times the height. Substitute in the area of the base based on the shape. If the shape is a circle, it's pi r squared. If it's a cube, the area of the base would be side times side. And then if it's a pyramid and it only has one base, you need to multiply by a third. So you can usually just figure those out in a moment. But those are some of those that they expect you to know. Cylinder, or I went back and forth on typing this up. The volume of a sphere, this one they always put in the question if you need it. So you might still write that you don't need to know that one for sure. We do lots of questions with sphere stuff, but they always provide the formula. So. Okay, anything y'all want to clarify about that? Okay, then let's look at, before we work on the number 41 worksheet, I'd like us to do this card sorting activity. So you want to get these out, work with your neighbor. This one has 3 sets of cards to match up. Okay, so these cards, there's 3 different colored cards for The green cards are a scenario. So these could be like a related rate question. So you need to match up the green card with the geometry formula that would be needed to solve that related rate, which is a pink card. And then if you were to take the derivative of the pink card, what would its derivative be, which is the purple card? So you don't actually have to solve the question. You just need to try to pair up the question with the needed geometry formula with what its derivative would look like for the purple card. And then when you think you are done, let me know so I can check them. And maybe give you some feedback. And the sooner you get this checked off, the more time you can spend on that number 41.
From this equation that you have to use.
I've done that a couple times. I looked at the jeans. They have good shirts, but the jeans were.
And there's no tricks to these. Everything pairs up with one card. So probably in your interest to try to pick off the ones that sound the easiest first and then build up to the ones that sound harder. Pink is the original geometry formula, purple is the derivative. You need a green card to go with pink card to go with purple. Again, you do not have to actually work these out. Just pair them up, figure out which ones go with which.
Oh, well, we need to read the question.
What? That's not smart.
High algebra age would be.
But we just listen.
Yes. Feel
Yeah, that's all.
in height.
Just skip that one right now.
I do know that the triple
Those are fine, so you can get those put away.
Take that in.
So this one is, this one.
No, definitely no.
is
Because I don't want you to just change answers and figure out. You might pick the same wrong answer, which is helps me know that we need to look more detail.
This is a tricky question, I think.
Probably not. Usually get it. Well,
Yeah, if you use product rule for the base kind of height in the original one.
wait, let me see.
I was doing a rectangular prism, which is just base times height. But since this is, you're multiplying, you have to use product rule. It's a trick
Yeah,
question.
it's not a trick question. You just
It's
do
a
that.
trick question.
I know, but like, wait. This is cylinder.
Is that so? Yeah. Oh, yeah. There, that is the example. Stay, be a card, good card.
This one's so. I don't understand how it could be.
Yeah, this has to be it.
I don't understand how it can be into.
Well, is that the same thing you had?
Yes.
Well, so I agree with this being the derivative of this, but it doesn't go with this one. But these two go. Okay, I agree with you. This, and that's his derivative. So these two should be okay. Yeah, these go together. But your scenarios are
This is trying this right triangle.
okay. Well, this is the SOHCAHTOA equation. That's a SOHCAHTOA equation. That's a diagram example. All of those have right triangles. SOHCAHTOA is also a right triangle.
Remember for cone, it might be this typo. If that should, if this is a derivative of something, that two still has to be done.
What do you have on now? It is so good.
So we have the hypotenuse. And we have the adjacent we call it.
So these two. I had a question about the
this. We have the distances of the area of the
By elimination.
Your website? The videos are up. Or I can, it was just unit.
We finally got the smartboard.
What?
We finally got the smartboard.
They're all worth
What's weird is the smart one runs all the way over there.
You didn't turn that thing on one.
That always goes up. Every time I get all of these. Ever. Want to see this one picture of me? Hilarious. I went to school like this last year. And every spring colors that have to take the final. So I went to school and it was like, horrendous. Barely. Like barely, because I don't know how I made it. Like, I don't. Wait, where is it? Oh my god, there's so many. Wait, where'd it go? Oh, the answer was way too on my armor.
Scramble up in the bag, and then it's long worksheet we started last week.
It's so small and then it's like going around. And my eyes are like not. It was like,
Committed to the,
huh?
you're committed to the assignment.
I was. Not really. It's just that I hadn't been so committed that I had to commit at one point in my life. It was the last class period, like that we'll ever have.
And you want to do final.
No, I was not taking the final for that class.
I want to take the final. Especially for this class.
What's your test? That's right, that's right. Wait.
Everyone's like panicking. Everyone else is gonna lose.
Yeah.
I'm good at those, put those away. Don't bring something
Do you have this?
No, it's about the chapters 1 through 7. Chapters 1 through 7.
That was a weird read. It's like random.
That was the worst book I
I don't even like what he's talking about.
I still don't know. Wrote an essay, don't know. Don't understand. Don't think I'll ever, don't ever want to understand.
Getting to
Yeah, just like trying to. She graded the whole essay. 198. That's
scared of that. Did you write it all?
my dad. She gave me a low grade.
These are the ones that I agree with, so those can go away in
My
the back.
grammar and my
These
spelling
are-
was perfect.
I had something mixed up,
Perfect.
so you gotta try these
I was
three.
like, that's surprising.
Some parts of them may have
I
not.
never really would have found out.
They weren't all matched
Well,
up.
this one is.
Just you, babe.
All three of these are. Okay. Part one or just do like.
Part two is all the changes.
You did do that.
Yeah, these are all the changes. The last one. This is live.
Is that what you wrote?
Why are you taking them off?
Good?
Are we long?
These are the ones you're wrong.
Can I take these?
Some parts of these might have been away, but they weren't all right. Yeah, put these all away in the bag before you retry. Okay, what is the change?
well,
Why?
This one have the length of A and B and try and find C, so you can use that. And this one you have the hypotenuse and the adjacent angle, so you can use cosine and it. And this one.
Wait, okay.
I feel like we should probably match the pinks and purple stuff and then, yeah.
So this has to be it.
I mean, it's opposite and adjacent.
Yeah.
The limb's going up and there's a difference.
Yeah, that's what I thought.
This one
Okay,
matches this one.
that's good now.
Yeah, that's how
So put the rest in the bag,
Then we may have had them.
and then the big worksheet we started on last class. Started.
Upstairs window. They want to water. This is the back of the
So this one.
That's what I thought originally. Oil spills.
For a circle.
Oh, wait.
Before.
Because it's wrong the first time, so it can't be.
That's alright. I just make sure to see like here what.
Oh, this one is this one.
Yeah, this one's measuring the side that the hypotenuse goes to, and then everything to go with. Yeah, because that oil. That's
Those are good. So you can scramble those up. Find the create worksheet 41 that we were working on.
This has to be it, or I will cry.
Oh, yeah.
Good enough.
Good enough. I don't
What's
get
wrong
it.
with it?
Nothing. I said it was good.
You said good enough. What is that supposed to mean?
They're fine. They're right.
Oh, you know, getting the answer right is good enough.
Well, I thought he meant we have to be positive, he said good enough, and he just gave up.
Those are all right. So scramble them up and
Like, all
back.
right. Have no faith in him.
Okay, anybody still need me to check their card and store? Okay, so if you have not, you need to pick back up on that long worksheet 41. This will be the last big chunk of time I can give you all the work on that. Some of those questions on number 41 are harder than others. I was reworking some during advisory, and like number 6 is very tough. You might want to skip that one and try it later.
6?
Yeah, number 6.
On the front or in
Second half?
On the second half of it, not the front page. I'm not telling you not to try it, but don't invest 30 minutes in it.
I'm gonna invest an hour in it.
Okay, well invest 1 hour, but save it for the last question.
Yeah, it's homework. I think it's homework, if we don't finish. So like, I mean the ground is crazy. It's like actually pretty theoretical.
You know it.
Skip 6.
I would save it for the end, personally. I mean, if you're feeling like super confident, there's nothing wrong with giving it a shot. It's just you have to dig a little bit deeper on that one. And how they call things P, Q, and R really, in my opinion, makes the question harder too. But
Yeah, I wanted to break out the area presentation, but I don't know how to do that. It isn't super To be honest, first is a number.
yeah,
You busy?
no.
Everyone said that 6 was super hard, but like, is this how you find the rate that the area is increasing? Because I feel like that wasn't too complicated. So maybe I'm wrong.
Well, did you get these two answers?
You're supposed to just get like a square root.
Yes.
Okay, well there's one. Where's your?
I don't know how to do diagonals,
Well, diagonal is just this.
so I do the a squared.
Yeah, you can just look at this as a right triangle to do this.
So I need to do 2 of these. Like I need to do the a squared, b squared, c squared.
Yeah, it's kind of like two questions. I think when they're saying number 6, though, they're talking about this number 6. See, front page has 1 through 6, but then the numbers restart after that. This number 6.
Everybody's skipping this one because they thought you said it was super hard, which it's not.
Okay, I don't know. I'll have to. I guess I'll work that one too to be sure.
Should that be 15 times the square root of 10?
Are you on the second?
These are a lot easier than I remember. On which one?
6 on the second half.
Yeah, that's the one that I said is the hardest.
Oh, I thought it was 6 with the P's and Q's.
That is the one on the second half.
She means the
No,
second
the second
half
half
of
of the
6
first
on the
number
front.
6. The
Oh.
diagonal.
Oh, okay. I haven't worked that. Give me just a second. I didn't even work the first page because I thought y'all finished the first page yesterday.
answer is supposed to be oh, that's why. Because you have a simplified. So you have to multiply both sides by square root. Both things by square root. And the bottom is like 2 times square root. You know how you have to multiply both sides. Square root 2 by 3 is 10, and then square root 6 is 8, and then you can simplify.
25 is 50. 5 square roots of 2.
Which is what that says. That makes more sense. It's just simple. You're not supposed to square root on the bottom. You multiply on the bottom of 10. Square root of 10.
The second part is 6.
6 times 10 on the top. And then when you simplify it, then it's so oh, I see what happened. So you just need to simplify. You need to simplify that first to make it 8 over 5.
Everyone else is
Okay, I did the second half, and I got the same yesterday.
Show me yours.
Yeah.
Well, 8 over 5.
Okay. Even though I do want you guys to work together on this,
It wouldn't hurt.
pause temporarily.
Yeah.
I've gotten a couple questions about the number 8, part 2 on the front page. So if you need help with that one, please follow along. Otherwise, if you don't need help with that one, please just work on a different one quietly for a minute for those people that need this one. Again, this is going to be number 6, part 2 on the front.
I did that, and I put it in the column that's
What? Okay. Listen, I'm doing something. I'm going over number 6, part B. This is from the front page. Okay, part B wanted to know at what rate is the diagonals increasing. So, in this question number 6, you had a square where the lengths were 5 centimeters. That carried over to part 2. At what rate is the area increasing? So you're looking for A prime. Or no, I'm sorry, that's the first part. The second part, at what rate are the diagonals increasing? Well, this would be the diagonal. There's also a diagonal here, but they're increasing at the same rate. So for this, you need to focus in on the right triangle. A squared plus B squared equals C squared. Take the derivative. Maybe divide everything by 2 to make it look a little bit nicer. Is everybody okay with this so far? For part B? You know why I'm using Pythagorean theorem? Okay, and then in the question, so if I call this A and this B, A is 5, B is 5, C, how could I find C? Okay, so what's that going to make this length? Okay, very good. You could do Pythagorean theorem, or if you know your special right triangles, either way you could end up with that as 5 square root of 2. And we're trying to figure out the rate that the diagonals are increasing, so that's C prime. And the rate
of the side lengths increase at 3 centimeters per second. So that would be A and B, because both of those are sides of the square, so they're increasing at the same rate. So you get 15 plus 15 is 30. Divide both sides by 5 square roots of 2. You could simplify your fraction to get 6 over the square root of 2. And honestly, I don't know if you guys are aware of this, but unlike in trigonometry, calculus, we generally don't rationalize the denominator. It's not a big deal like it is in pre-cal. Okay, so again, I had 2 or 3 questions about this one, so that cleared up everything you needed. For those of you that got stuck on that one. Okay, while I have your attention, on the next page, has everyone tried 1? And does anyone know if you need help with number 1 yet?
Could you just explain what we need to do?
Well, it's the same with every question. Maybe draw a picture. Maybe pick out a geometry formula. They've already done that for you. Always take the derivative of the geometry formula with respect to time. So you need to take the derivative of that, which is going to be product rule. R squared times H has to be product rule. You plug in all the information, and then you solve for what you need. I mean, that's the only skeleton I can give you of the question.
So we can just use the formula in the books?
I don't think they always give you volume of a cone formula, but I did show you guys how to derive that on our first handout this morning. Okay, what about number 2? Anyone tried that one, got stuck on it, and would like some help? Number 3? Number 4? Number 5? Again, I'd probably save 6 for the end. I think that one's just a little bit more involved. But you're welcome to try it, but don't just get stuck on 6. Move on. Has anyone tried 7 and need help? Or 8 and need help? Has anyone made it to question 9? Okay. Okay, it sounds like you guys may not know where I need to help yet, so go ahead and keep trying. And again, I know I said this last time, and I feel like I shouldn't have to say it, but these last 2 pages, all these multiple choice, the answers are on the back page. If you just pick the answer and you have no work, I'm not giving any points for that. If you're doing your work on a separate sheet of paper, make sure that you keep it with it so that you turn it in with it. None of these questions are easy enough to just do in your head, so there should be something.
here. X prime is the same thing as y prime, 3y prime. And if you make that substitution temporarily, you can solve the problem. Well, where's your geometry for you? Well, if you have A and B, you could get C from memory and brain. I think the one thing that usually is not a space here, is they don't use this part. I think when you plug all this in, you're still gonna have two unknowns. I don't know right here, which one's your x prime, so it's 3y prime. So you can temporarily change your x prime to 3y prime, or you can change the y side to 1 third. You can make that substitution, and narrow it down to all. In your problem over here, you're using a but x prime is 3y prime. So I think that works. So at some point, instead of saying a prime, you could say 3.
Oh, that's fine.
It's kind of weird when you name it different. Yes, when you make that substitution, you get one equation and one. That's not enough.
Well, it's R times H, so it's a product.
The geometry, so we need to label these links. Like, we know how this is changing, but we also need to know if we should call this x and maybe call that y.
It would be H would go like H prime, right? Because like the single variable just goes to 1.
So we call this x. So the geometry formula is the one that you need to take a derivative of is a2 instead of and you have a small triangle inside of a big triangle like this.
So like 1/3 R is
The ratio of these two small link compared to big link. And they do the same thing here. Small link compared to big link.
R prime.
So that's the geometry. It's not Pythagorean theorem or anything like that. You got to make those proportions. Then when you cross multiply, and you divide that term.
I'm living on the outside. It makes it
Now you
easier.
just take the
It
derivative of
gets
that.
super complicated if you try to add it in. That's where yeah, that's
How much did you list? No, number one, this Well, it's like half of this unit. What are you gonna do? Just tank half of the unit? Let's go. You gotta start somewhere.
Confused on 3. Is it a triangle?
Okay. You need a picture.
Yeah, so 8 meters above ground street light. 8 meters above ground street light.
Okay.
There's a 2 meters tall box directly away from the street light.
Yep.
The shadow's length. So is this the shadow length?
Where's your person?
Right here, I guess.
So he's 2 meters tall. The shadow is going to create when the light hits the top of his head and then hits the ground.
So
Triangles. Is that the triangle? Yeah.
oh.
So you know his shadow right here. If you call one of these things X and one of these things Y. Do you remember doing like proportions? With that type of problem?
It looks something like this. You need to label those, both those unknowns. So in geometry, when you have a small triangle inside of a big triangle like this, they're similar triangles, which means they're same shape but different size. But you can make a ratio out of a couple of the lengths. So small length compared to big length, and then small length compared to big length. That's the proportion. Then when you cross multiply and combine like terms, what's up with that? That's the geometry formula they want you to use in this question. It's not Pythagorean theorem.
I would have never thought that.
This proportion? You don't remember doing that in geometry?
I was geometry and I had Miss Baker, so. No.
Basically, if you have a triangle inside of a triangle, the sides are proportional. So you compare it small length to big length equals small length to big length. And then this is the geometry formula they want you to take the derivative of.
Okay, let me just solve that.
Oh, that's, I see.
So I was on grade 2, and I drew which variable would the 4 over 9 meters per second? Would it be the y variable?
Because this is the light source.
Yeah.
So when the light source hits his head, this creates this would be what you would call your shadow if you were standing there. So what you're calling y prime would be the 4 numbers.
Yeah. And then I'm trying to find x prime.
Yes. But right here, I'm a little concerned. Just going from here to here, your derivative's messed up. The derivative of is this 2x?
Oh, there's no x.
Yeah, and
no
there's
y.
and no y there.
Yeah.
The x prime has to be there, and the y prime has to be there, but there should not be an x or y.
What's the X? Is that for this? What's the exit five?
Well, one of them is what the question's asking you to solve, and one of them is we're not.
The rate in meters per second versus walking. So
If you're standing here,
the Y,
well, I don't know if you labeled yours the same as me.
I labeled everything the exact same.
This is you, and this is the light source.
Okay.
The light source is hitting your head, this is your shadow.
1 unit a second.
So that's the one you know the rate of. So to me, that was X prime, but I don't know if you labeled it. This is how fast he's walking away.
Okay.
So for me, this prime, Y prime is what I solved.
Okay.
So wait, is y prime equal to x prime in this case then?
No.
That's-
If you're walking, your shadow is not necessarily moving at the same rate you are, because it's at an angle. I'm not saying that it could never be, but it would be a coincidence. Okay, where are you guys at? Number one?
Oh, X 100
Oh,
is
that
3
was
times.
Are
hard.
you good with that one?
Yeah.
Okay, what about number two? Started.
For which question?
I didn't do that. I got like this far.
Okay, well, let's see.
You should ask them.
You need an X prime here. Because you're not taking the derivative with respect to x. Related rates are always with respect to time.
Wait, so
You can divide everything by 2.
so it says before plugging this in the X prime.
Sure, it's just simplified. It's just 300 here.
Oh, wait, this is instead of
You know what's happening.
Yeah.
Okay, and then you start plugging this stuff in. E prime is 1.
Wait for diagram.
When x is 4,
Okay.
y is 3.
So you guys diagram here. Let's try it.
You're trying to solve for x prime, so x prime probably needs to stay there for now. And move left and move solve for it. Okay, we don't know y prime. It's true. Come back to that. But we do know z prime is 1. Okay, you don't know z yet. But if you know this is 3 and this is 4, you can do Pythagorean and solve for z. Okay. Alright, now the issue becomes we are trying to solve for x prime, but we don't know y prime. We've got 2 variables in there, right? So then we can use this temporarily. So instead of saying y prime would be equal to 1/3 x prime.
We should
So make, instead of calling this y prime, call it 1/3 x prime. And then, don't you have numbers and everything except for x prime? That's how it's very simple. You just have to force yourself to start plugging stuff in, otherwise you don't know what else to do.
Yes.
Because I know this is what the right prime is. Does this mean that the rate is
This is changing it really. What does this mean? This means the rate of x prime is the same thing as 3y prime. So lost.
I really don't know what the first step is.
Yeah, because you need to have the geometry formula, they tie it all together. Plug in the values that you have.
then you start to identify what it is you don't
What
want.
are you
So this is like a very, I'm still on
Oh.
I just have, I know what to do, I just have to put it all like.
It would be hard to describe.
First one,
So I know.
you wrote hard.
So I know on this, when I study.
So you come up with the geometry formula, you take the derivative, plug in the values you have, and then you know how to do it.
Because the rate of change is changing by 1 unit per time. But 0 is not changing. It's increasing by 1 unit.
Specifically,
Question 2 is just kind of weird. This is part of the strategies of the x prime is equals to 1 times
you don't need to still make a picture, you can still take out a geometry formula, you can still do the derivative, you can still plug in the values. I don't know Okay, so you're pretty close. So at the end here, I think you should know how to use cubes. So I think you have 2 variables. But this is saying now your x prime. X prime is the same thing as 3y. So you can make a substitution, that substitution and get it down to 1 over. Okay. Hey, you gotta do the picture, you gotta fix the geometry formula, you can take the derivative, you can plug in the stuff you have, and then worry about what all the other stuff is.
Wait, so I still have 2 variables.
Well, I just put the 1/3 out front of the parentheses. That's just a number. So then I did the derivative of r squared is h plus 1 plus the derivative of h plus r squared. But I think they give you all that information. So you got the next product here. You do the product of r squared, right? But last one.
But it's asking the price.
I should have I just the numbers, so I'm not concerned.
Oh, I got
And the r squared and the r squared.
So you just multiply it out.
Yeah, it's the same as now we know what's the derivative of 5x squared? What's the derivative of x squared? So the 5x squared, its derivative is just 5 bigger. So this guy, 1/3 pi, his derivative is going to be 1/3 pi bigger than if it wasn't there at all.
Okay.
So I just put the number out front because I don't want to copy it.
I've got 2 questions. So number 6, which side first is the lead? Never mind. I was about to ask something.
That's such a weird question.
I was
Those
thinking-
are hard. First one.
And my second question is, what do you think of the company? A little lucky. I'm not a guy.
I got nothing to say about it.
Have you never seen
I mean, if you hadn't told me I was a company, I wouldn't have guessed something.
Maybe you should see.
What is the price? Oh my gosh.
I'm sure someone's already made one. The problem is the pumpkin's on a real sphere, so it's kind of.
Well, it's not even that.
Yeah, actually, if you took like each slice, you know, like how it's kind of rounded and bumped, if you took each slice and did the volume that way, that would be something that would count. You could see.
I ain't taking that, that's for sure. If I had one.
Very similar to what we do. It's just
Negative.
you would find the volume of one little slice and then you multiply by 5 or 6, whatever, however many slices it would be.
D. Oh yeah, D. I'm in D.
If I buy a pumpkin from Walmart and find the volume of it, can I get a bonus point?
I don't get those points.
Actually, I was just
earn
thinking
the regular
water.
points.
Same with water. This one.
So, we're supposed to find the radius of, or the change in radius of a circle that's equal to the circumference without actual pull back.
Well, when you said change in area, that sounds like derivative. So take the derivative of the area of the circle formula. So, what's the area of a circle?
These are both going to be r squared.
Okay, so the rate of change of its area would be, no, you can't put that there. That's what A equals, not what A prime equals. You need a new line. So A prime equals,
Prime is times r, which is the same as
you're missing this. R prime, there you go, okay. So now you know the rate of change of the area. Now do the same thing with circumference.
my pencil.
You may have that down there, I just can't read it very well. Circumference is equal to what?
Circumference is 2 pi r.
So what is the rate of change of circumference? What's the derivative of circumference?
Both r and pi would be regular values.
PSAT is on Wednesday, right?
R should be.
You're not plugging in a number and then taking through. You're taking the derivative first. 2 and pi are just numbers. Well, what's the derivative of r? What's the derivative?
I'm taking PSAT.
So the derivative of circumference is 2 pi r prime.
I don't think I'm gonna
You
get
gotta
it.
write that down.
Just try.
Derivative of circumference is 2 pi r prime. Okay. So you want to figure out when the rate of change of area is the same as the rate of change of circumference. So set these two things equal to each other and you can solve for r.
Oh! Your computer's guarantees. Depends.
Which one can I help with?
Scholarship on what they because really what's gonna matter is what the cheapest is.
And number 4?
Yeah. In-state is just maybe like
Yes.
This is the hardest one though. That's what I was saying. You might want to save that one for at the end. It's a lot harder than some of the other ones are. Yeah, that's all for ours.
So would I take R and then I just do this
No, I read it out, but I couldn't
and
figure
then
out
divide?
which.
You don't even have to do that stuff. I mean, this and this are the exact same thing. So you should just be dividing both sides by the 2 pi r prime. There you go, you're done.
Yeah, I'm gonna try. I'm trying to get a picture.
That's one part of what's hard about this. They refer to it as Q and R. P is always opposite. P1, R is opposite, equal R, and Q is opposite. But I don't like to use R, P, and Q. I like to use so.
I'm just gonna try to get that.
Okay. It's maybe one of the things you got to figure out.
Yeah, I've never studied it.
But you still have to figure out the geometry.
This time I think that I could do better.
What geometry formula you're gonna use for that
My issue is a lot of times I'll like forget the math stuff, and I end up not doing well in math, and like higher math classes than I end up doing in my other classes.
Then start plugging stuff in to see what you don't.
Yeah.
I don't have A and B.
Okay, but I don't see the rest of your work, so I can. I don't know. Your A and B might be different than mine. You're choosing what you want. I'm not going to be able to look at your work that quickly and answer. I can show you my work, but you need to see where you actually.
That's the one that I think I can do like really well on, and help like bring my other stories up a little bit from that. Yeah, up a little bit.
Okay.
Yeah, because I'm in ACT test prep right now.
No, so then it's asking for your X.
I think you're pretty close, but like I said, I can't just look at that one. There's too much going on. I can let you look at my work. I don't know if you labeled the same A, B, and C as me.
I'm just
Like
kidding.
you did. A, B, C. So Pythagorean theorem, derivative. Use that to make this substitution. You may have put that in. I think it should have been on there. Or you might be taking a slightly different approach, I don't know. But you're close to right here. But then what I saw, both of these had a B prime, so I factored it out. And if this times this equals 0, either that could be 0, which isn't helpful, or this could equal 0, which gave me what B is in terms of A, and then I can redo Pythagorean theorem. And that's why this one's so hard. It's very hard to figure out how to use those against each other. That helps or not?
So it's going to class and then this is like the distance away from and this is
I think that's one in a couple years
I don't know.
I couldn't figure out, but like, because the shadow, the concept of that, like would the shadow be this?
Well, this is the light source. This is the top of your head. So the light source is the top of your head. It's going to keep going. There's another small triangle.
Well, because like, yeah, if you walk farther away, the angle's going to be bigger.
So if you look like this, here's the top. And then, if you call one of these things X and one of these Y, you don't know what it's on.
The angle.
You can do a proportion.
You put in the calculator as sine with opposite proportions.
That's the usual. But you can take small length to big length, 208, instead of equal to small length over big length, X over X plus Y. Then you can cross multiply.
I figured it'd be radians since it's
Find my term.
Yeah, I would
trigonometry.
think so too. Yeah.
Are you on 6?
It's 8.
This type of picture.
I skipped 6 because I didn't even read it.
Yeah.
I'm just trying to finish as much as I can.
What Flash of Revenge?
That is really big.
Was it the name?
The shadow lengthening is X.
So that's right. Is it not fine with the entries?
So you're supposed to find,
How much X is increasing?
yeah, non,
Weird, because you don't have any numbers.
what's the equation?
Would it not just be so controlled? No.
Wait. It's just cosine?
I'm trying to get over it.
Cosine? Should I try cosine?
Because it's a 3, 4, 5, 10.
Let's try that. I don't know how it.
What does it say the answer is?
And then when you divide it, you divide both sides.
12.
I haven't been checking my answers.
I think what we're looking for, yeah, Y prime. Y is
They're just behind the whole
what is oh, that's what we're yeah, that's right. I wouldn't know that, but okay. Is it probably I don't
I don't agree with this derivative. Drop the power down, lower the power by 1, let the distance derivative of r with respect to x. So this one also needs an r prime. Now, if you divide both sides by a 2, a pi, and an r prime, so all that stuff cancels out. There you go. You're done.
So it is an answer.
Well, you got a little bit left. You forgot that part of your derivatives.
this instant
We're almost done. This is the rate of change area. This is the rate of change of pipe. What happens is you divide everything by 2 pi r
It's 6 all around. I didn't cheat off of you.
Oh, on the front. We did that one on the board earlier.
Yeah, but I didn't look at it.
competitive.
Like say in the situation, I'm like master jujitsu.
It's Friday, so we can hit
It's not all about strength. It's about experience. I think I'm master jujitsu. I think it's too big. I know who's what. I don't like it. Hear me out, hear me out. Okay. Swing sex. I slip on him, get on his back, choke him out. He's passed out. He falls forward.
Zero chance. Zero.
Next camping trip, I'm gonna
More
plug down a
likely to
bear.
be negative probability than positive.
I'm gonna bring you a bear that I fought off and choked out in the woods. Hey, I'm gonna hunt the bear.
Well, it's nice to know me.
I'll bring it like Beowulf and
You'll
the
get to
monster.
kill it and then do that.
No. I'm gonna choke it. I'll drag the whole bear for autopsy.
And then you remember stick shit.
Ooh,
Well, y'all don't listen to half what I say.
Okay, that's not even true.
Yeah, it's just Christian.
Yeah.
Here.
No plus with that.
Okay. Where's your geometry formula? Where are your derivatives? Where are you
Well,
plugged
I'm
in stuff?
bears.
Sine.
Oh, number 8, I'm sorry, I'm looking at it.
Oh.
Slip.
Okay. Where's your equation?
I don't know what to do. Sine. Sine.
If you want to. So you could say sine theta equals
Equals.
opposite, which is x. We don't know it.
Five.
Hypotenuse.
But then you take the derivative.
Okay, so what's the derivative of sine theta?
Cosine.
Almost.
Cosine.
It's cosine theta and something else.
Theta, right?
Theta's not the same as t.
Oh, what is? Oh, keep that.
What's the derivative of 2x?
2x. Where'd you get 2?
What is the derivative of 2x?
2?
What's the derivative of 3x?
Oh. It's 1/5?
There you go.
Oops. This is too much.
And?
X prime?
Yep. Okay. So, cosine theta, you can get from your picture, was 4/5, adjacent over hypotenuse.
Okay.
Theta prime, I think, is what you're solving for.
Yeah, you got that. We're solving for it.
So, then plug this in for,
Okay.
and then the last thing is what you need to solve for.
Oh, man.
Number 8. I don't like training out I said lost is what the first step should be.
The same as all the other first steps.
Yes.
They're all pictures. Pick a geometry formula that's going to tie up. You start labeling this stuff. What is this stuff?
One of the geometry formulas that we're going over is covered.
Well, this geometry formula is going to be a set of equations. Just like your matching. You do sine theta equals opposite over hypotenuse. That's the geometry formula. Sine theta equals x over 5. And then take the derivative.
My computer have to be in radius. Put cosine that in. I'm just not getting it.
No, that's not how that works. For a cosine function, you would plug in an angle, not a ratio.
Yeah, so how do I do that?
It's right there, cosine of theta. So when you're looking from theta, what's his adjacent side?
4?
And his hypotenuse.
5.
So the cosine of theta is 4/5. It's not cosine of 4/5. It's cosine theta is 4/5.
Okay.
So that's
That
good.
makes so much more sense. That's why I'm so confused.
Mr. Townsend, always a pleasure discussing how to take down a bear. But we've only got a few minutes left.
You got more than a few.
I misunderstood the timing.
That was wrong.
Mr. Townsend,
Yes.
how would you do number 6?
That's the long one.
Oh,
So I can't give you a quick answer, but if you want to take a picture of my work, we'll probably have to talk about it at some point.
thank you.
Okay, guys, we're down to about 5 minutes here. So, if you notice on homework, you still don't have to have this fully complete, but you really should try to
Finish another question or two. You really need to narrow down which ones you're going to get stuck on and have a couple more finished so that you're a little bit closer to being done. But it does not have to be finished by next month. If you feel like you're falling behind on it, you probably should do more than a couple to catch up to everybody else.